Okay, so 2-1, solutions from standard form to factored form. So let me zoom this in a little bit for you. So recall that quadratic function written in factored form is in the form f of x equals a times x minus r1 times x minus r2, where a is not 0, and in factored form, r1 and r2 represent the x-intercepts of the graph. So this says determine the zeros of the function z of x equals x squared minus 16. Then write the function in factored form. So if you were to graph z of x squared minus 16, and you've graphed that out, I'm just going to draw a quick sketch here. It would start at negative 16, and it would move up 1. So it would be at negative 15. So it's going to start there and go at negative 15, because remember the pattern is up 1. So that's at negative 15. Then it goes up 3. So that would be at negative 12 and over 1. Then it goes up, so up 1, up 3, up 5. So that's going to be at 3, 5, which is going to be at negative 7. And then 1, 3, 5, and then 7, and that's going to be at 0. So that's our parabola, and then it's going to go this way here. And it went over 1, 2, 3, 4. So it's going to go 1, 2, 3, 4 this way, and you're going to see the intercepts are at 4 and negative 4. So if we're graphing a quadratic function, x minus 16, remember the 16 is negative, so we go down 16. We use the 1, 3, 5, 7 pattern, and you can see the intercepts are 4 and negative 4. So in factored form, guys, determine the zeros. The zeros are x equals 4 and x equals negative 4. So factored form, z of x equals x minus 4 times x plus 4. The function z of x in factored form is called a quadratic function made of two linear factors. Let's analyze the linear factors as separate linear functions, g of x and h of x. So therefore, z of x is, this is g of x, and this is h of x. Okay? So it's a product of those two. So it says complete the table by writing the algebraic expressions to represent g of x. So g of x we're going to say is x minus 4, and h of x is x plus 4. And then z of x is a product of those, which is x squared minus 16. And we're going to plug in these numbers. Negative 4 minus 4 would be negative 8. Negative 4 plus 4 would be 0. Negative 8 times 0 is 0. Negative 2 minus 4 is negative 6. Negative 2 plus 4 is 2. Negative 6 times 2 is negative 12. 0 minus 4 is negative 4. 0 plus 4 is 4. Negative 4 times 4 is negative 16. 2 minus 4 is negative 2. 2 plus 4 is 6, and we get negative 12. 4 minus 4 is 0. 4 plus 4 is 8, and we get 0. And so if we look at the linear models, they're already graphed in there. And if we look at our quadratic, you're going to see that at negative 4, the answer is 0. Right? At negative 2, it's negative 12. Sorry, it's counting by 2s. I missed it by 1. And then at 0, it's negative 16. And then that turns and goes back the other way, just like I drew up above. And so if we draw this quadratic, it looks like that. Okay? So there's our quadratics, our two linear graphs, and our quadratic. If we look at the zeros of each linear graph and then of our quadratic, you'll see that the zeros are negative 4 and 4, and that is the 0 of our quadratic. So when we're trying to find the solutions, we can find the solutions to each of the factors, or we can find the solution to the entire quadratic. So the zero product property, super important. This is like one of the really important algebra rules. The zero product property states that if the product of two or more factors is equal to 0, then at least one of the factors must equal 0. Okay? So if we have here x squared minus 16, the factors are x plus 4 and x minus 4. That means either x plus 4 is 0 or x minus 4 is 0. And if we solve that, means x is 4 will give me 0, or x is negative 4 will give me 0. So zero product property, the factor is equal to 0. You set each factor equal to 0 and solve. If we plug in 4 squared minus 16 is 0. If we plug in negative 4 squared minus 16 is also 0. So we've now solved. So explain how the zeros of the linear function's factors are related to the zeros of the quadratic function product. So the zeros of the linear function factors are x equals 4 and x equals -4. And as the quadratic function, the zeros of that are also x equals 4 and x equals -4. So the zeros of the factors are equal to the zeros of the product of the factors. The function z of x equals x squared minus 16 has an a value of 1. So there is no number in front, so we know that's 1. And a b value of 0, because remember it's ax squared plus bx plus c. So if there's no x term, it's going to be 0. So we could write this as 1x squared plus 0x minus 16. And you see a is 1, b is 0, and c is 16. You can use similar strategy to determine the zeros of a function when the leading coefficient is not 1, if v is still 0. So we're going to use find the zeros of this function by setting f of x equal to 0. So 0 equals 9x squared minus 1. So how are we going to find our factors? So what this is called, if we have two terms, both perfect squares with a minus in between, this is called difference of squares. And when factoring difference of squares, what you're going to do, and you could put this in a calculator and find the values, but we're going to do this instead, is you take the square root of the first term. So the square root of 9x squared is 3x. And then you take the sign and then the square root of the second term and you put down 1. And then your second factor, as we noticed up here, is always the same thing with the opposite sign. So then 3x squared, or 3x plus 1. And then we can check this. If we do 3x times 3x, we get 9x squared. 3x times 1, we get 3x. -1 times 3x is -3x, and -1 times 1 is -1. If we simplify that, we get 9x squared minus 1. So our factors are 3x minus 1 and 3x plus 1. And if we use a zero product property, they're equal to 0. That means we set them each equal to 0 and we solve. So x would be 1/3 and x would be -1/3. And now we have our solutions. If we plug those solutions in, 1/3 squared is 1/9 times 9 is 1, minus 1 is 0. -1/3 squared is 1/9 times 9 is 1, minus 1 is 0. And you can see, oh, sorry, I didn't realize I was off the page. You can see both answers equal 0. So these are the solutions to this quadratic function. So you factor difference of squares, set the solutions factors equal to 0, and you find your zeros or your solutions. So then it says the graph of 9x squared minus 1 is shown. Graph the linear factors. Our linear factors are 3x minus 1 and 3x plus 1. So let's go to our graph, 3x minus 1. This is slope-intercept form, y equals 3x minus 1. Y equals 3x plus 1. So we're going to start at -1 for the first one. We're going to go up, and be careful because the scale is not, if you count, make sure you watch the scale. So we're going to start at -1 and go up 3 and over 1. Up 3 and over 1, down 3 and over 1, and draw in that line. So that's the first equation, y equals 3x minus 1. The other one's +1, so we're going to go up to +1. And we're going to go up. Sorry, I messed that up because I forgot to watch the scale on the x-axis, or the y-axis. So we start at -1, and we're going up 3. So this is 1, 2, 3, and over 1, which is over here. So it ends up in the same spot, but I should count it out correctly. Sorry. And then the other one starts at +1, and it goes up 3. So 1, 2, 3, and over 1. Or we can go down 1, 2, 3, and over 1. And if we draw that line in, it looks like that. And then we should see that our intercepts are here and here, which if this is scaled by 1, it's at 1/3 and -1/3. So those are our zeros that we found on the previous page. So you can graph these out and see that that shows. How do the zeros relate to the zeros of the quadratic? They're the same. So now for this section, for each of the functions, you're going to use Desmos or the graphing calculator, and you're going to graph the function. And then you're going to find the linear factors and find those values. So if we go on to Desmos or graphing calculator, see if I can get my graphing calculator battery to last long enough. And we go 4x squared minus 9. And we're going to graph that. And we get the parabola. And now we're going to factor this using what we talked about. So take the square root. And we're going to get 2x minus 3 and then 2x plus 3. So now we're going to go back to our y equals. We're going to put the second equation as 2x minus 3 and the third one as 2x plus 3. And then we're going to graph. And you should see nicely that that crosses at the first 0. And this crosses the second 0. So you can just graph this. It says take a picture of your screen or a screenshot if you're doing it on Desmos, and make sure you either stick the picture right here at this problem. Okay? You don't have to do this one because I'm doing it, but stick the picture at the problem, or you can send me the picture separately. I just need to see the picture that you did this part. So we graph this, we determine the linear factors, and we're going to simplify these. So we're going to get 2x equals 3, x equals 3 over 2, and then 2x equals negative 3, x equals negative 3 over 2. So those are our solutions. It says put them on the graphing calculator, take a picture, and show me. If you want to find the solutions on this, you can do second, calculate an intersection. And I want to intersect my blue with my red, but I want to have them intersect up here. And then it tells you it's 1.5. So there's the answer. And then I can do second, calculate, intersect, and do my blue over here with the black one. And again, you'll see the negative 1.5. Okay, so that's the way you can find the values on there. So then it says determine the zeros of each linear factors, and it says decimal answers will not be accepted. So if you get a radical, simplify it, don't give a decimal. Okay. So you are going to do the same thing on B and C. So what we just did there, do that on B and C. And again, either attach your picture right in the document, send me a picture separately, however you want to get me the picture on either Desmos or your graphing calculator of your screen so I can see that you did this part. You should be looking for those intersects and making sure they match up with your answers you get here. Okay.